Hello everyone. So let's continue to the questions of chemical bonding and molecular structure. Let's start. Okay, so we are at question number 16. So question number 16 is the d orbital involved in sp3d hybridization is. Options are dxy, dzx, dz square, dx square minus y square. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C, and the solution is the dz square orbital is involved in sp3 hybridization. In sp3 hybridization, one s and two p orbitals combine to form three planar triangular hybrid orbitals. The remaining p orbital may combine with dz square orbital to form two axial orbitals. Hence, option C is the correct answer. So, moving on to the question number 17. The hybridization of orbitals of n atom in NO3 negative, NO2 positive, and NH4 positive respectively are. Options are sp, sp2, sp3, sp2, sp, sp3, sp, sp3, sp2, sp2, sp3, sp. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer is option B. First, we count the sigma bond, lone pairs, and then unpaired electron, or count the number of atoms directly attached to the central atom. So, in the case of NO3 negative, that the oxidation state is 1, and this is the structure. In the case of NO2 positive, this is the structure, and in the case of NH4 positive, this is the structure. And you can see in this table sigma bond is given, lone pair and unpaired electron, and the total the hybridization is given. So for sigma bond number 3, which is in NO3 negative, the hybridization will be thrice of sp2. In the NO2 positive molecule, the sigma bond will be 2, and the total hybridization will be twice of sp. And the sigma bond is 4 in NH4 positive, and we have the hybridization for sp3. So option B is the correct option. Let's move to question number 18. The states of hybridization of boron and oxygen atoms in boric acid, that is H3BO3, are respectively sp2 and sp3, sp2 and sp3, sp3 and sp2, sp3 and sp3. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option will be option B, and H3BO3 structure is this, and boron has 3 bonds, as you can see, directly attached to the oxygen, thus sp2 hybridized, and each oxygen atom has 2 bonds and 2 lone pairs, hence sp3 hybridized. So we can say that it is sp2 and sp3 hybridized. Hybridization state is present in the boric acid. So option B will be sp2 and sp3, and the option A will be sp and sp3. Okay, so the correct option will be B. Okay, so let's move to question number 19. Match the following and choose the correct option. So we have column first here and column second here. So column first has these molecules SF4, IF5, NO2 positive, and NH4 positive, and it has the column 2 has the hybridization states like sp3d2, sp3, sp, sp3d. And options are A4, B1, C3, and D2, A1, B3, C2, and D4, A3, B2, C4, and D1, A3, B1, C2 and D4. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So SF4 has 4 bond pair and 1 lone pair, so it will be sp3 hybridized. IF5 has 5 bond pair and 1 lone pair, so sp3d2 hybridization. NO2 plus has 2 bond pair and 0 lone pair, that is sp hybridization. And NH4 positive has 4 bond pair and 0 lone pair, that is sp3 hybridization. Hence, the correct answer will be option A. Let's move on to the second question, next question, that is question number 20. Isostructural species are those which have same shape and hybridization. Among the given species, identify the isostructural pairs. So options are NF3 and BF3, BF4 minus and NH4 plus, BCl3 and BrCl3, and NH3 and NO3 minus. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. The species BF4 negative and NH4 positive both have 4 bond pair and 0 lone pair. Thus, they are sp3 hybridized. Therefore, both these species have similar shape and hybridization. That is, they are isostructural species. Hence, option B is correct answer. Let's move on to the next question. That is question number 21. In which of the following pairs the two species are not isostructural? Options are CO32 negative and NO3 negative, PCl4 positive and SiCl4, PF5 and BRF5, ALF6 3 negative and SF6. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. And CO32 negative and NO3 negative given in option A are triangular planar structure. PCl4 positive and SiCl4 having tetrahedral structure given in the option B. Option C has PF5 and BRF5 which has trigonal bipyramidal and square pyramidal shape. And in the option D, ALF6 3 negative and SF6 is given which has octahedral shape. Hence option C is the correct answer. Moving to question number 22. The number of lone pair of electron in I3 negative ion is. Options are 3, 6, 9, 2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. The structure of I3 negative ion will be this. You can see here the structure I, and it is attached to the two iodine atoms, and they have the total lone pairs as 9. So hence 9 is the correct answer, hence option C is the correct answer. Moving on to the next question, that is question number 23. In XEF2, XEF4 and XEF6, the number of lone pairs of XEs and non respectively are. Options are 2, 3, 1, 1, 2, 3, 4, 1, 2, or 3, 2, 1. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. The xenon atom has 8 electrons in its outermost shell. In case of XEF2, out of these 8 electrons, 2 are used for bond formation while 3 pairs remain as such. That is, it has 3 lone pairs. In case of XEF4, 4 electrons of xenon are used for bonding. Therefore, number of lone pair, that is non-bonding electron, is 2, And in case of XEF6, 6 electrons are involved for bond formation. Thus, the number of lone pair is only 1. Hence, option D is the correct answer. Moving on to the next question, question number 24. The structure of IF7 is, options are square pyramidal, trigonal bipyramidal, octahedral, and pentagonal bipyramidal. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option D. So in IF7, the ground state of electronic configuration will be this. So in 5s2, 2 electrons, and 5p has 5 electrons and 5d has 0 electrons. But in excited state, 5s has 1, 5p has 3 electrons, and 5d has 3 electrons. And on combining these single paired electron filled orbitals, the hybridization is coming out as sp3d3. That is one orbital of sp, 3 orbitals of p, and 3 orbitals of d. So sp3d3 hybridization. This is the structure you can see here of IF7, and the structure of IF7 is pentagonal bipyramidal. Hence, this is the answer. Moving on to the next question, question number 25. Which has trigonal bipyramidal shape? Options are XeOF4, XeO3, XeO3F2, XeOF2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. So in the XeOF4, 5 bond pair and 1 lone pair are present. So the square pyramidal shape will be the shape of the molecule. In XeO3, 3 bond pair plus 1 lone pair will be present. So the shape will be pyramidal. In XeO3F2, 5 bond pair and 0 lone pair will be present. So trigonal bipyramidal will be the shape. And in XeOF2, 3 bond pair and 2 lone pair is present. So the shape will be the T shape of the molecule. So the shape is trigonal bipyramidal. If a compound have 5 bond pair and have 0, that is no lone pairs. So this is present in the case of XeO3F2, and this is the structure of XeO3F2, which is having trigonal bipyramidal shape. Hence, the correct option is C. Let's move on to the next question. Question number 26. The shape of IF6 negative is, options are trigonal distorted octahedron, pyramidal, octahedral, or square antiprism. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option will be option A. So the number of hybrid orbitals we can count by this formula, H equals to half of V minus C plus A plus M, where V is the valence electron of central atom, C and valence electron of central atom C, and A equals to positive and negative charge respectively. C and A are positive and negative charges respectively. M will be monovalent atoms. So in IF6 negative, H will be equal to half 7 minus 0 plus 1 plus 6, coming out as 7. So hybridization is sp3d3 and structure should be pentagonal bipyramidal, but it contains 1 lone pair and 6 bond pair. Total pairs are 7. So 1 lone pair and 6 bond pair. Hence, its actual geometry is trigonal distorted octahedron. So the correct option will be the A option. Moving on to the next question, question number 27. The molecular shapes of SF4, CF4 and XEF4 are. Options are different with 1, 0 and 2 lone pairs of electrons on the central atom respectively. Different with 0, 1 and 2 lone pairs of electrons on the central atom respectively. The same with 1, 1 and 1 lone pairs of electrons on the central atom respectively. The same with 2, 0 and 1 lone pairs of electrons on the central atom respectively. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer is option A. So SF4, which is having sp3 dehybridization, CF4 having sp3 hybridization, and XEF4 having sp3d2 hybridization contain 1, 0, and 2 lone pairs respectively. Therefore, their shape will be also different because they have different number of lone pairs and they have different type of hybridization present in them. So the shapes of their shape will also be different. Hence, the option A is the correct answer. Moving to the next question, question number 28. The structure of which of the following chlorospaces can be explained on the basis of dsp2 hybridization? Options are PdCl4 2 negative, FeCl4 2 negative, CoCl4 2 negative, or NiCl4 2 negative. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be A option. Although Cl negative is a weak field ligand, but in case of PdCl4 2 negative, it pair up the electrons of palladium and results in dsp2 hybridization because of the large size of palladium 2 plus. In all other options, pairing is not possible, so hybridization is sp3 with tetrahedral structure. Hence, option A will be the correct answer. Moving on to next question, that is question number 29. XEF4 molecule is tetrahedral having options are 2 p pi d pi bonds, 1 p pi d pi bond, 4 p pi d pi bonds, 3 p pi d pi bonds. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. The structure of XeO4 molecule is given below and it contains 4 p pi d pi bonds. You can see here the structure of XeO4 having 4 p pi and d pi bonds. Hence, the option C will be the correct option. Moving on to next question, question number 30. Which of the following spaces is not paramagnetic? Options are NO, CO, O2, or B2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. To identify the magnetic nature, we need to check the molecular orbital configuration. If all orbitals are fully occupied, species is diamagnetic, while when one or more molecular orbitals is or are singly occupied, species are paramagnetic. So in option A, that is NO, total electrons will be 15. And on filling these 15 electrons in the orbitals, we have this electronic configuration, orbital configuration. We can see that one unpaired electron is present here in the 2px. Hence, it is paramagnetic. In the option B, 14 electrons is present and we can arrange the 14 electrons in the orbitals and the orbital configuration will be this. We can see that no unpaired electron is present, all are fully filled. Hence, it is diamagnetic. And in the option C, O2, 16 electrons are present and we can arrange these 16 electrons in the orbitals like this and we can write the molecular orbital in molecular configuration, orbital configuration in this form. And we can see that two unpaired electrons are present here and here in 2py and 2px. Hence, it is a paramagnetic molecule. And in the option D, B2, 10 electrons are present, which are arranged in the molecular orbitals, and we can write the orbital configuration in this way. And this has also two unpaired electrons in it, like in pxy and 2py and 2px. Hence, it is also paramagnetic. So the correct option will be B, that which is diamagnetic. The correct option will be the diamagnetic one, as we have asked in the question. Okay, so moving on to the next question. Question number 31. Which of the following order of energies of molecular orbitals of N2 is correct? Options are first one, the most in 2p z square, then pi 2p square of y, then which is equivalent to 2p x square less then sigma star 2s2, then sigma 2s2. Most in pi 2p square y equivalent to pi 2p square x, then sigma 2p square x z, then sigma star 2s2, then sigma 2s2. The option pi 2p square y, then pi 2p square x, then sigma 2p square z, then sigma 2s square, then sigma star 2s2. Fourth option pi 2p 2y, then pi 2p square x, then sigma 2x square, then sigma 2p square z, and then sigma 2s2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. And the correct increasing order of energies of molecular orbitals of N2 is given below. That is, the most in sigma 2p2z, then equivalent in 2p2x and 2p2y, then sigma star 2s2, then sigma 2s2, then sigma star 1s2, and the least in sigma 1s2. So this is the correct order of energies of molecular orbitals of N2, right? Okay, thank you.